Welcome to the new Calculus channel. I am John Gabriel. In the previous lesson we discussed what is a tangent line and how it is defined. Now in this lesson, which is lesson 4, we're going to discuss what is a secant line and how to find the slope of a secant line. So very briefly, the secant line is a finite line segment whose endpoints lie on a given curve. It is possible for a secant line to intersect the curve in more points besides the two endpoints of the secant line. The slope of a secant line is found from its endpoints, as I shall show you shortly. Okay, so let's look at the applet again. So here is a demonstration of secants. This particular secant has a gradient of 35.38 tangent ratio. That one has 34.05. This one here has 14.5. This one here has 29.4. So really, a secant is basically a finite line that intersects a curve in 2 points. Okay. So how do we find the slope of a secant line? Well, let's see quickly. In this particular diagram that I have over here, if the coordinates of this point are x plus n, f of x plus n, and the coordinates of this point here are x minus m, f of x minus n, then the gradient of the secant line is given simply by f of x plus n minus f of x minus m, all divided by m plus n. Yes? Do you see that? So if you draw a line down there like that and a line down there like that, the x-axis, this is the x-axis. Let's suppose parallel tangent is over there, okay? Then this distance here is m, and this distance here is n. Okay, so the entire distance obviously is m plus n. And this here will give us the slope of the secant line, okay, which is f dash of x, presuming that that point there is x. Okay. So that's basically how we find the slope of a secant line. Now, let's go back to the applet very quickly. We can see that if we have a secant line like so, we could draw a parallel tangent line right over there, which would have the same slope. As long as the curve is both continuous and smooth, we can always construct a parallel tangent line. What does it mean to be continuous? Simply this: there are no gaps in the curve, and it is defined everywhere. What does it mean to be smooth? Simply this: you can construct only one tangent line at every point of the curve, not more than one. So for example, if we go back to this diagram over here and we take a look, let's just see here. So if, for example, let's choose a different color, blue. If we wanted to know if this part of the curve here is smooth, well, if we can construct exactly one tangent at every point, okay, at every single point in this interval, I could probably blow that up like that. I could represent this section here like this. Whoops. These are points. I'm just magnifying them so you can see what's going on. So if we can construct only one tangent at every point, only one, then we say that interval is smooth. And obviously if it's both smooth and continuous, then it doesn't matter where these spots are. If we have a secant line there, we can also construct a parallel tangent line over there. Okay? And so that's pretty much it for secant lines and their slopes. In the next lesson, we'll take a quick look at secant and tangent lines and realize there is a unique tangent line that is parallel to all the secant lines in the same interval. And so that ends the lesson. Lesson 4, what is a secant line and how to find its slope. I'm glad you could join me. This is John Gabriel, and you've just watched Lesson 4 on the New Calculus channel. I hope you can join me for the next lesson. Thank you.